So, hi students, welcome to the checklist of modes of heat transfer, saturated vapor pressure, and kinetic theory of gas we call KTG. This series is to help students to have a maximum in-depth of concept in minimum possible time, and by trying as much as possible to talk around all the concepts and topics in physics. We are about to finish the part one of our space syllabus, and we move to the part two in the next section, which is waves and electromagnetic waves. So to start with today, if you find anything interesting, please kindly subscribe to the channel and share with your friends so that this can actually get to them as well. Don't be selfish in any process. We start with the first question. The modes of heat transfer which do not require material medium is dash. Now, from the modes of heat transfer, there is a particular mode of heat transfer we call radiation, which is electromagnetic in nature, which do not require material medium because they are electromagnetic. So the correct answer to that is radiation, as conduction and convection are not electromagnetic. So please keep that in the back of your mind. Radiation was explained better by Joseph Stefano, which we have studied in our junior classes. So the correct answer is radiation, not to waste time to answer this question as quickly as possible. So the answer to this question is radiation. There's no doubt about it. The next one. The vacuum in a thermos flask helps to reduce heat transfer by dash. Now, like what we talked about just now, we said radiation is a mode of heat transfer that does not require material medium, as heat can be transferred through vacuum. Electromagnetic wave can pass through vacuum. So please understand that. So for non-electromagnetic wave, the conductions and the convections, they cannot be transferred through vacuum, as we have already discussed. So please keep that at the back of your mind. It's a simple question. The concept of mode of heat transfer is not difficult to understand if you have gone through it, and that is why we are doing this kind of checklist to help you to understand how the answer is this. So from what I said, thermos flask is just a flask that is used to prevent to actually reduce the minimum loss of heat. So to do that, there are some steps and methods we take into practice. One of them is by using the vacuum, which we call a small space, to reduce heat loss by conduction and convection. So please note that. And to stop radiation, we use a silver sulfate or shiny surface. According to Joseph Stefan, like I talked about, we talked about emissivity of body and absorptivity of body, and we use the black body as a case study. So, but for now, UTME and for your standard, I only limit it to what is going to be asked. So I'm not going to go in details into that. Just keep in mind, conduction and convection cannot pass through vacuum. Radiation does, and to reduce radiation, use shiny surfaces, because we believe what black body are good absorbers and good emitters. I think that's the only major thing you need to know under this concept. We move to the next one. Question 3. About question 3, we said, which of the following phenomena explains the fact that a house whose roof is coated with white paint will be cooler in hot season than the one coated with black paint? Yeah, very good. Now we say white paint and black paint. I just talked about conduction now. I said black body. That is just the simplest explanation you might have read in your junior classes. Black bodies are good emitters. Black bodies, BB, that is the way I've written it in my concept video. Black bodies are good absorbers. So always keep that at the back of your mind. And because black bodies are good emitters, they are also good what? Absorbers. Now, when it is incident on the body, they either will transmit it, emit, or absorb it. Then the sum total of how they transmit and emit it, or how they absorb it, is now the measure of the black body, which I call the black body radiation. So black bodies are good conductors of heat, whereby shiny surface are bad conductor. They don't absorb like black body. So the absorptivity of black body is very. And talking about why a roof of house is coated white is cooler, it is just because black will conduct, because you are saying good absorber. When you absorb, you are conducting. So let that be known. So it is because black will conduct it more than what than white. So the principle you can talk on those your modes of heat transfer is conduction. As you know that refraction and reflection are not the modes of heat transfer. Keep that at the back of the mind. The next question. About the next question, what we have here is the graph which represents the variation of the mean kinetic energy of molecule with temperature T degrees Celsius is that. Now, this is concept of KTG, kinetic theory of gas. The main kinetic theory of gas from how we were able to do this, we use the Maxwell curve, using the Maxwell equation. The concept is available on kinetic theory of gas. And for those of you who are actually following up on the series, you will understand that we said the measure of average kinetic energy is the measure of temperature. So basically you think, okay, because when we increase temperature, the average kinetic energy between molecules will increase. You are going to what? Cancel this. You might want to what? Cancel this and think the answer is this. Now, let me be quick to tell you that the mean average kinetic energy is given as the kinetic energy, which we denote by U. Concept video is important, is equals to 3 by 2 kT, where K is the Boltzmann constant. How we come about this was from the what? The mean, the graph of what? The Maxwell equation, where we plot the velocity at the speed of what? Of gases against their what? Temperature. So K is called Boltzmann constant. From here, and you can also say U equals to 3 by 2 nRT, as you can change K to what? nRT. So now, I don't want to teach too much of concept, as this is just only on what? Understanding the concept might be important, but I will take you through important. Now, my point now is the temperature is in degrees Celsius. That is the technicality. You can see new pattern where by some of the students will be like, I am supposed to get everything. There are some technical questions that you don't attend to well. So in this case, you can say U, which is average kinetic energy, is equals to 3 by 2 K into brackets. T can be small t plus 273. What have I done? I have converted this thermodynamic state to what? You can see T is the same thing as what? T plus 273, which you know. Now, if I try to expand this, my dear student, this should give me, sorry, I have to go through this because I can't just speak answer without explanation. 3 over 2 KT plus, I have a 3 over 2, you can see, 3 over 2 times 273 K. I hope you understand this. And if you don't understand this, I have only expanded. So now from my equation of slope, y is equals to mx plus c. If I actually look at here in terms of k, you can see, my dear student, here, I can say that what? The value of my m, setting them equal, what I always call by symmetry. So we have, you can see, please watch, with respect to temperature, this one is having a positive slope and a positive intercept. So, and there are some values. It is not starting from rest. So because of that, this answer is valid and this answer is not valid. So please always keep that in mind. Mean kinetic energy, which is basically from Maxwell velocity curve, is always equals to 3RT by M, square root of 3RT by M. About derivation, I've done that for most of these level classes for my physics channel here. You can always go through it. But the most important thing for you is just the application for the UTM student. You don't need to know that much. You only need to know only what is required in your syllabus. But because of the new pattern, that is why we are talking about all these stuff, because this is what we see in what the most recent years. Now, the next question, we have, if water is gradually added to a few grains of table salt in a glass cup and left unstirred, there is water that is added to a glass cup that contains salt. The old water will eventually taste salty because of what? I think this is not stuff. You are not eating it, so you forget about mode of heat transfer. So it is more like saturated vapor pressure or a little bit of your chemistry. It's a process whereby you call it is not rise and fall in a narrow tube, because narrow tube is not what? It's what? A glass cup. Place a glass cup has a wide what dimension. So you can cancel this. It is not supply. As you can see, you can cancel this. And you are left with two principal phenomena you might have studied in your junior classes or in your chemistry classes. Now, about this, the answer to this should be diffusion, because the mode of the movement is what we need to know. Now, we say diffusion is the movement of fluids from the region of higher concentration to that of lower concentration. You are pouring it the salt from the top, and it's going down to the bottom, and it's going to what? Circulate. So we pick diffusion, and I think from your junior level of understanding the concept of diffusion and osmosis, most especially biology students, I don't think we should have any issues with this. Osmosis require what? A membrane, a semi-permeable membrane, the way your teacher might have defined that in your junior class. So please, I will leave that like that, as I believe that's a cheap question for every one of us to handle. About the next question. A block of aluminium is heated electrically. Heat transfer, yet again, by 25 watt heater. That is the power. As power is measured in watt. If the temperature rises from 10 degrees Celsius in 5 minutes, as you can see, I have to convert 5 minutes time to seconds. I'll just say 60 multiplied by 5. Everybody knows that is 300 seconds. The question asks for the heat capacity of aluminium. According to Jamb, 1823, I've talked about this time and time again, heat is equivalent to work. Heat can be converted to work. So you always keep this at the back of your mind. Heat can be converted to work. And because of that, just give me a minute. I will join you guys soon. Please just. So now from here, from the conservation theorem, we have also studied that energy lost in form of heat is given us, in this case, because we have time, we have power times time, is equals to MC change in temperature, which you write as the theta. So it has been converted to work. As you can see, the power is 25 and multiplied by time. The time is 300 seconds. Remember, its capacity is what is asked here, and the heat capacity is given as a product of mass and specific heat. So this is what we are looking for. We are looking for MC. Please keep that at the back of your mind. So MC, let me just call it Y, multiplied by change in temperature is it rises what? It rises the change in temperature by 10 degrees Celsius. So I'll convert also that to Kelvin. So the theta is equals to 283 Kelvin. I hope you understand that. I have added 10 to 273 to have 283. So on simplification, Y, which is the heat capacity, will be 25 times 300 divided by 283. I think now we should be able to do this. This should be 25 times 300 divided by 283. Maybe you should try that. Like I do say, I don't have calculator, so it will be difficult for me to tell you the answer to that. But I know you guys should be able to do that. And if perhaps your conversion is not giving you what you need, you can decide to use 10. So because what I'm saying here, with respect to the answer, that means the what? The temperature is not converted. That is the truth. So if we want to go by temperature not converted to Kelvin, like I do say, you have to follow the line of question, though it is an error from the examiner, to be honest, because these are in Kelvin or per Kelvin rather. So this should be 283, but I think because of the nature of the answer I'm seeing here, 10 was used. So it's now simple as this. We cancel this 25 times 30 is 750. So which is the correct answer according to what the examiner provided? Do you understand? Which is not actually the correct way, to be honest, for Waec students because of your theoretical examination. You follow the standard of conversion, please. The next question. Now, about the next question, like I just said, I'll be leaving some of the questions for you guys to solve, the calculations for you to punch and drop your answers in the comment box. Now, this is which of the following statements are not correct? I think we are still on saturated vapor pressure concept. Now, both the boiling point and the saturated vapor pressure will depend on external pressure. Fine, correct. Boiling point is said to be the temperature at which atmospheric pressure is equal to the vapor pressure. We've talked about that. This is correct. The next one says we are looking for which is not correct. The saturated vapor pressure rises with temperature. Yes. Saturated vapor pressure is the measure of what temperature. That is why if you increase the saturated vapor pressure, the temperature of the substance will also be raised. So always keep that at the back of your mind. So because SVP varies directly as temperature. Please, is very correct. The next one is the saturated vapor pressure is independent of the volume available for the vapor. No, this is wrong because SVP also depends on the volume. Because if it is in a confined state, that is a very tight corner, the vapor pressure will be less. But if the volume of the container is high, the vapor pressure will be high. So keep that at the back of your mind. Look at the last one to actually verify that answer. It is possible to boil water at lower temperature uh, than 100 degrees Celsius at high altitude. Very good. Very correct. This is very correct because as you move up the mountain, what you are doing is what you are reducing atmospheric pressure. And as you reduce atmospheric pressure, you are reducing what temperature. Because we said saturated vapor pressure is a measure of temperature. So when you boil water on top of the mountain, it boils at a temperature lower than what? Lower than what? 100 degrees Celsius. So please keep that at the back of your mind. The correct answer to the question here is this, and we write this as the answer. Are you okay with that? Fine. The next is our kinetic theory of gas, and we have a question on your formulas. Now we have a quantity of gas occupies a certain volume when the temperature is, maybe this is negative 73 degrees Celsius, I don't know. But when we solve, we are going to know. And the pressure is 1.5 atmosphere. If the pressure is increased to 4.5 atmosphere and the volume is half at the same time, what would be the new pressure? We have pressure, volume, and temperature. From gas law, PV equals to nRT. I think we did something like this also yesterday. Now, if you are taking nR to be constant, it will be equals to PV by T. So if the process is been changing as a thermodynamic process, for UTME, you guys are lucky. Your thermodynamic process questions are always simple. So if nR is constant, PV over T is written as P1 V1 T1, has now changed to a new state of P2 V2 over T2. Concept, which I believe you've studied more, or this is called what we call general gas law. And this is the way you do that. So you just substitute the value. I will not be doing this because I believe you can do it. The first pressure was 1.5. I will help you write the parameters 1.58 here. Then the first volume, certain volume, we take the first volume as Y. I just use Y. The volume was half, V2 was half. Half of Y is Y over 2. And when that happened, it increased the new pressure to 4.58 here, 4.5. So the question is the initial temperature was also given, which I call T1 at 73 degrees Celsius. Answers are in degrees Celsius. So the new temperature is what you are looking for. That is that question. So you are looking for T2. Substitute these parameters, excuse me, and get the answer. 1.5 times the first volume is Y over the first temperature. The first temperature is 73. Then is equals to the first pressure is the second pressure is 4.5. times the volume has now reduced to y by 2 over what you are looking for. I'll call it capital letter T2. So on simplification, like I said, I'm supposed to leave it for you. You can cut a lot of things. Y gets cancelled out, as you can see. So this is like, you can also say year 1, you can cut from year 3. It's simple to do that. So that I can now say I want to cut. This is 3 over 2, 1.5 times 7 times 73. So it's just 73 times 1.5 that will be my answer. So that's that. Like I said, I will leave it for you to drop the answer in the comment section. So I think this should be about 110 degrees Celsius, approximately, from what I think. So you can just confirm that and drop your answer in the comment section. So the next set of questions, which is more likely, I think the last set, I'm not sure. We check again. Water shows anomalous behavior between the saturated vapor pressure. Water shows a kind of anomalous behavior between the 0 degree, a popular question, and 4 degrees Celsius. The density of water is solid to its point of maximum, then it's later come down. So at that point, we say water behave anomalously. So it is not at 0 at 4, but it is between 0 and 4 degrees Celsius. I hope you have studied this also your chemistry topics. Now, I think maybe the last one, because this is number 10, if I'm not mistaken. Which of the following phenomenon cannot be explained by molecular theory of gas? We have talked about that before. This is under mode of heat transfer. And the thing is what the only one that cannot be explained is what the one that is electromagnetic. And we talked about electromagnetic out of the modes of heat. We talked about what radiation. We don't need to waste time because we have studied this concept before. So let's check if we have more. Wow, I think this is the 9th one. So about this, if 1.2 times 10 raised to power 6 joules of heat energy is given off in 1 second from a vessel maintained at a temperature gradient of 30 km per kilometer per meter, the surface area of the vessel is dash. The surface area of the vessel is dash. So let's see this. So now the question answers to the area. I think this is question on rate of flow of heat. The concept is also important. The rate of flow of heat is given by the Q by the T, and it was given as that is always equals to K A, change in temperature, we say the T by the L. Now the T by the L, which you have seen there, the T by the L is called the T by the L is called temperature gradient. So this question is incomplete because I will show you we're given the Q by the T, you can see in 1 second. So this by 1 is 3 this. But we are not given thermal, there should be a bracket. Thermal conductivity of this material should be, so that you are going to get the value of it. The T by the L is 30, as it is called temperature gradient. So please, you can see when you see a question like this is the way you are going to do it. So the last question, a liquid boil when it's saturated vapor pressure is correct. Let's just be fast. The source substance involved increased boiling point, yes, correct. When the external pressure of the material, when the external pressure is increased, boiling point is increased, this is also very correct. Then the source substance decreased melting point is wrong. So the correct one here says which combination of the boiling is what of the boiling point of the liquid. So this is correct. All others are very, very wrong. So I will stop here, guys. I will meet you guys tomorrow morning by the grace of God. So see you soon. Thank you and bye bye.